Hi everyone, what's up? Today I want to go over a very cool example of the FTC2 and the chain rule. So in a previous video we went over how you can use the FTC2 and the chain rule to compute the derivative of some functions that are written as an integral where the upper bound is another function, okay? So this is just pretty much the chain rule where the outside function is a function written as an integral, okay? So that's what we did in a previous video, and today I want to do an example using what we discussed in that video, okay? So let's recall first of all that the FTC2 says that if we take the derivative d over dx of a function from a to x of the dummy function f of t dt, well, this derivative is going to be equal to f of x, okay? Now, this is a dummy function. Maybe if you haven't heard that, if you haven't heard that term before, this is just a dummy function because, well, it's just a placeholder. You know, it's something that we have to write, and that its only purpose is to indicate, well, what function the integrand has. You know, it's, I mean, the only thing that we really care about is that the upper bound is the input, and really the integrand is something that is not as relevant. Okay, it's just gonna be like a placeholder. Okay, a placeholder for a function, so that's why we say it's a dummy variable. So yeah, if you haven't heard that term, well, it's worth mentioning that. So yeah, now let's get into the problem. So this is the FTC2, and of course, well, f has got to be a continuous function. That's one condition. So the example that I want to do today is this one. So let's say we have a new function. I'm just gonna say this function is gonna be g of x, and let's say that g of x is gonna be equal to the integral from 0 all the way up to sine of x squared. Okay, so this is gonna be the upper bound. Of course, it's gonna be a function so that we can use FTC2 and the chain rule. Okay, so now the dummy function that I'm gonna use is gonna be let's say sine of t times let's just say tangent t. Okay, dt. Okay, so this is the dummy function that we have. Now, what if we want to find the derivative of g? Well, let's see how we can do that. So we have g prime of x is going to be equal to, so let's see what we can do. So since we have an inner function, well, we know we need to use the chain rule, okay? So I'm going to be, you know, very clear in what I do. So I'm going to write explicitly the substitution that I'm using. So I'm going to say that the substitution that I'll use is going to be equal to sine of x squared, okay? So I'm just creating a dummy variable. This is a dummy variable that is going to store the value of sine x squared, okay? Sine of x squared. So we can now compute g prime like this. So we're going to take the derivative with respect to u first, because this is going to be the outside function. And when we use the chain rule, remember we take the derivative of the outside function times the derivative of the inner function. So we have d over du of the integral from 0 all the way up to u, which in this case, well, u is going to be sine of x squared. And the dummy function that we had was sine of t times tangent of t dt, okay? And since we're taking the derivative of the outside function, well, what about the inner function? Now we're going to multiply by the derivative of the inner function, okay? Which we know is going to be du over dx, okay? Now, du over dx is pretty interesting because u is also a function of a function. Sine is an outside function, and x squared is an inside function. So technically, if you wanted to compute, you could compute du over dx as another chain rule, and you know I could define explicitly another variable, but I think that you already know that du over dx is just simply going to be the derivative of sine, the derivative of this function times 2x, okay, the derivative of the inside function. So I'm not going to write a new dummy variable, but just so that you keep that in mind, du over dx is going to require us to use again the chain rule again, okay? So that's something, you know, worth mentioning. So now, how can we compute this expression? Well, we know that this left-hand side factor is going to be, we can compute it using FTC2, and we know is going to be equal to the dummy function, and you can just switch the input from t to u, okay? So let's see what that would give us. So we get over here that g prime of x is going to be equal to the dummy function. So that is going to be sine of u times tangent of u. And now we have times the derivative of this function. So I'm actually going to write it like this so you can see what I mentioned about the chain rule being used again. Prime, okay? And this is with respect to x, okay? So, well, how can we compute this? We know u is going to be equal to sine of x squared. So this g prime is going to be equal to sine of x squared, okay, times tangent. So this is going to be a tangent. Let me write that t again. I was going to make a plus sign, and I don't know why, but yeah, this is supposed to be t. So we have tangent of sine of x squared times this derivative with respect to x. Now we know this is going to be, I'm going to compute this real quick. Now I'm going to compute it. Do I have space here? Yeah, I do, yeah. So this is going to be 2 times. So now the derivative of the outside function is going to be cosine. So we have cosine of x squared. And now the derivative of the inside function, the inside function, if we see it with respect to the fully outer function, which is g. So the derivative of the inside function, which is going to be x squared, is going to be 2x, okay? So I'm going to write here 2x. And now, is there any way I can write this in a better form? This is going to be, you know, the final result for g prime. So I don't think there's any way to write this better. This could be sine, you know, you could put these two together and you would get sine squared of sine. Yeah, I'm actually going to do that because this is kind of too long. So let me, and this is going to be cosine. Oh, let me see if there's anything now. Yeah, I can just simplify it in one way. Let me show you how I would simplify it so that it looks better. So I'm going to say that g prime of x is going to be equal to, so we would have, these are just the same input. So this is going to be sine squared of sine of x squared. So this is going to be sine squared of sine of x squared, okay? This is sine squared because recall tangent is equal to sine divided by cosine. And over here you have sine times sine over cosine. So you get sine squared in the numerator. And you're going to divide this thing by cosine. That is going to be, yeah, cosine. So we have cosine of sine of x squared, okay? So this is what we get. And of course, we just get times cosine times 2x cosine. So yeah, I'm just going to write this here. So this is just going to be times 2x cosine of x squared. Okay, so yeah, I'm going to leave it in this form. This is just, yeah, this is not exactly necessary, if you want to be elegant or, be as concise as possible in terms of the space you use in your notebook or in the board. Well, you can probably leave it like this. But yeah, anyways, this was just simplifying. So these two can be your possible results. This is how you can compute the derivative of this function, okay, the derivative of g, which is going to be this function, which is going to be a function that has a function sine with respect to another function x squared, okay? So that was, that was the different levels of functions that we had, okay? So yeah, this is a really cool problem. I hope that it has been helpful for you. You've learned something. And yeah, see you in the following video. Bye.